This is the part 3 of Introduction to Op-Amp. Here we'll look into several parameters of Op-Amp. So in this example, we have an Op-Amp without any input. So we are grounding both the positive terminal and negative terminal. And in this situation, your output should be 0. But if it happens that and in this condition, when there is no input at your terminals, you have a certain value of VO, which is called VO offset, meaning that you have, for example, 1 millivolt or anything. So this is due to the imperfection of your circuit. So meaning that there's supposed to be there is no output when there is no input. Okay, this is the ideal condition, but if you have something, that value is called the VO offset. Okay, so this is one way of to make sure that the output is 0 before you use your op-amp. Okay, the first way is by adding additional voltage supply at the input. Okay, we put a voltage over here and we set the value, so meaning that we change the value over here. This is called the VIO, the input offset voltage. Set this value until your Vout is equal to 0. So meaning that when at this particular condition, when your Vout is set to 0, so meaning that you have calibrated your op-amp. Okay, then only you can use your op-amp for other purposes. Okay, this is the second way of making the output is 0. Okay, just now we use the additional voltages, which is seldom used because other than plus VCC and minus VCC, we have to add in another voltage supply. And in this case, we use another 2 pins of op-amp, which is the input offset or null pin. Okay, so we connect it to the potential or potentiometer or variable resistor. So you vary your resistor over here until your output is 0 when your positive terminal and negative terminal is connected to 0, meaning there is no input at the side, so your output should be 0. If it is not 0, you vary your resistance over here until your output 0. Okay, this process is called nulling. So this is another way of make sure that your output op-amp is ready before you can use it. Okay, and we have said that for op-amp, for ideal op-amp, there is no current entering op-amp due to the high input impedance, which is infinity. Okay, we said that I plus equals to I minus and the value is 0. But in reality, there is a very small current around 0.1 pico to 10 microamp actually entering the op-amp. Okay, usually since the value is very small, we can consider it is to be 0. Okay, and we have the parameter which is called input bias current, and input bias current is the average of 2 of your I plus and I minus. It is called IB or I bias. Okay, so actually it is not 0, but the value is very small. And we have another current, which is the difference between the I plus, the current entering the positive terminal, and I minus, the current entering the negative terminal, and we call it as IIO or input offset current. Okay, actually ideally it should be 0, so I minus, you subtract with I minus should be 0, but since imperfection of your circuit, okay, you still have certain value. Okay, and due to this, your output is not 0 over here. Okay, when there is no input at the terminals, input terminals. Okay, so just now we define the I bias, which is the average of your input. Okay, and to eliminate this bias current, okay, since we said that I plus and I minus should be 0, usually we put additional resistor over here, Rx, where the value of your Rx is your R1 parallel with your Rf. With this, we balance the current entering the negative terminal and the positive terminal over here. Okay, and this is op-amp transfer characteristic. Okay, if you look over here, we have 3 region in the middle we call a linear region. This is non-linear positive saturation, and this part is negative saturation, also non-linear region. The maximum voltage swing of your op-amp is plus Vs or plus VCC. Sometimes we call plus V saturation. And at the negative terminal, negative saturation, we have minus VSS or minus VCC. Okay. Just now the picture is exaggerated. Actually, the slope is very close to your y-axis. Okay. So the linear region over here is actually very small compared to this. You will get a positive saturation if your positive terminal is greater than negative terminal, but you will enter a negative saturation if your V minus is greater than V plus or V plus is less than V minus. Okay, and just now we have mentioned that V out is equals to A open loop multiplied with the difference between the input terminal V plus subtract with V minus or VD. Okay, so this is actually we'll use that. Okay, if we compare the positive and negative terminal, that's where we get the positive saturation and negative saturation just now. Okay, if we say that V plus is equal to V minus, okay, in the last part, which is part 2 of op-amp, actually it is valid only at the center or the linear region. Okay, so this is where I said just now, the linear region, V plus equals to V minus and I plus equals to I minus, and the value is 0. Other than that, it will enter the saturation region. Okay, so this is the saturation just now, positive saturation, negative saturation. Okay, the linear is in between, so V plus equals to V minus is over here. So suppose that you connected your op-amp to plus minus 9 volt, which is your supply, plus minus VCC. I have mentioned just now the maximum voltage swing is limited to plus minus VCC. So your output cannot exceed this value, meaning that the highest you can get plus 9 volt or negative 9 volt. Okay, and remember that just now the equation for V out is AO multiply with the VD. So if you rearrange that equation, your A is VO divided by V in. Okay, so suppose that this is your voltage gain for your A open loop. Okay, so rearrange this equation, you'll get V in is V out divided by A. Your VO is limited by your supply, so it is plus minus 9 divided by the A open loop. So you have a plus minus 90 microvolt. So meaning that this is the maximum input that you can apply at the positive terminal and negative terminals. Okay, if you put your V in larger than this, you will get your output saturated. Okay, so this is an example of op-amp where we have a full swing. Okay, but this is an example of your output if it reach saturation region at the positive, at the negative saturation. So this is limited by the power supply. Okay, and just now we mentioned that op-amp, the output voltage depends on the A open loop, which is defined by the manufacturer. Okay, so we cannot control the gain. So usually op-amp is used using a negative feedback. Okay, and with the negative feedback we can control the output voltage and the gain of your circuit, but the gain will be much smaller compared to the A open loop. Okay, but still we use the negative feedback because with that we can control the overall gain and the circuit is more stable. Okay, your amplification is also linear, meaning that your output is less to noise distortion. Okay, and your gain is independent of the characteristic of your op-amp. Okay, and for any op-amp we have 3 input mode, which is called single-ended differential mode, double-ended differential mode, and another one is common mode. Okay, so what does it mean? So this is an example of single-ended mode, meaning that you put just one input at, in this case it is at the positive terminal. Okay, so that's why you call it as a non-inverting input, where you will have your output which is the same phase with your input. Okay, only that your input over here will be amplified. Okay, so this is called single-ended because we only have one input. Okay, the other terminal is connected to ground. As we swap the input, it is still one input, but now it is at the negative terminal. The positive terminal is grounded. You still have an output, but in this case your output is out of phase with your input. You have positive input over here, you have a negative output. Of course, the output will be amplified by a certain factor. And this is the double-ended mode. You have two inputs, both at the positive and negative terminal, and you get the output. So this is the differential mode actually. Okay, of course you get the amplified output. And the last thing is the common mode, where we have just one signal, but this signal is applied to both input, positive terminal and negative terminal, and you'll get no output. This is the common mode gain, which is the one that you want to reject. Okay, if you remember in your analog circuit, you learn about differential amplifier. So I have mentioned that op-amp is, the first stage will be a differential amplifier. So when you have input which is common to both input, your output will be 0. There is no amplification. Okay, so your SC, the ideal value should be 0. Okay, so those are three input mode for your op-amp. Thank you.